questions 21 through 25 on the 2016 Grade 10 Cayley Math Contest. In her last basketball game, Jackie scored 36 points. These points raised the average number of points that she scored per game from 20 to 21. To raise this average to 22 points, how many points must Jackie score in her next game? The total sum of all her points divided by the number of games is 20. That's how we got an average of 20. Straightforward. So S is 20N. Now, in her next game, that sum has been risen by 36 because she scored 36 points. Now, the number of games is N plus 1. So this average, they told me, is 21. All right. So I've got two equations, two variables I can solve. Cross multiplying here, we get S plus 36 is equal to 21N plus 21. So that means S is equal to 20N, so I can substitute that in. 20N plus 36 is equal to 21N plus 21, and therefore N is equal to 15. And there we go. There's 15 games at the beginning. Before she scored 36 points, there was 15 games, and then eventually there were 16 games. That 16th game, she scored 36 points. Now we want a scenario where S plus 36 plus something, that's what we're trying to figure out, over N plus 2 is equal to 22 now. This is basically what we want. So we have to now solve for X. S is 20N and N is 15. So substitute that in, plus 36 plus X, and then N is 15, so 15 plus 2 is equal to 22. Doing this math, we get 336 plus X is equal to 22 times 17 when you cross multiply, and when you solve, you get X is equal to 38. So 38 points is what Jackie must score in that next game in order to raise her average to 22 points per game. Number 21, therefore, the answer is A. Elaine and Louise are driving on a circular track with a radius of 25 kilometers. Elaine leaves the starting line first, going clockwise around the track at a speed of 80 kilometers per hour. 15 minutes later, Elaine starts. Louise leaves the same starting line, going counterclockwise around the track at a speed of 100 kilometers per hour. For how many hours will Louise have been driving when the two of them pass each other for the fourth time? All right. Well, it's a circular track, so obviously, let's draw a circle. And let's talk about this. So we'll break it up into the first time they pass each other, the second time, the third time, and the fourth time. So let's see. The first time they pass each other, we have, let's say this is the start, and Alan is going this way, and Louise is going that way. So eventually they're going to meet up somewhere. I don't know where, but let's just say they meet up here. And let's say the distance that Louise travels is X, and therefore I have to figure out the circumference of the circle. Circumference is pi times 2r, where r is the radius. And in this case, the radius is 25. So 2 times 25, the circumference is 50 pi. So the distance that Alan travels is 50 pi minus x. Now we use the formula speed is equal to distance over time, or time is equal to distance over speed, either one. And now when they meet, the times are equal. So that means distance, which is x for Louise, over her speed, which is 100, is equal to the distance for Elaine, which is 50 pi minus x over 80. That's his speed. But here's the thing. Louise starts after 15 minutes. First Alan goes, and then 15 minutes later, or a quarter of an hour later, Louise starts. So we have to think about this. We have to incorporate that quarter. How do we do that? We add it here. So a little bit of a tricky twist to the question that they put. All right, so at this point, this is now simple algebra. So we'll get a common denominator, multiply top and bottom by 25, and you'll get x plus 25 over 100 is equal to this 50 pi minus x over 80. All right. Cross multiply, I've got to isolate for x here. So 80x plus 80 times 25, 2,000. And then on the other side, 50 times 100, so 5,000 pi minus 100x. Okay, so it looks like it's 180x is equal to 5,000 pi minus 2,000. And then x is equal to this 5,000 pi minus 2,000 over 180. And probably helps if I get it to lowest terms. And in lowest terms, 250 pi minus 100 over 9. Okay, great. So, but I'm still not done. I've got to figure out the time. This just gives me x. X is a distance. In the end, I've got to figure out the number of hours, which is referring to time. So I got to figure out time, no problem. That's this formula, distance over speed. The distance is 250 pi minus 100 over 9. And the speed for Louise, that's who we're really doing this for, is 100. So this becomes, when it's all simplified in lowest terms, 5 pi minus 2 over 18. All right, so that takes care of this guy, the first. So put it in here, 5 pi minus 2 over 18. Now I think, man, this is going to be time consuming. Second, third, fourth. Well, there's some good news. The good news is that all of these are exactly the same. And I hope when I draw the next diagram, you'll understand why. Now we get to the second time they pass each other. They're starting here, right? So Louise and Elaine meet here. The second time they pass each other, I don't know where they meet, but I'm assuming that because Louise is faster, she's going to cover more ground. So Louise is going to end up here and Elaine is going to end up here. They're going to meet here. Now here's the thing. Unlike before where Louise started 15 minutes later, at this particular time, they're starting at the same time. So because they're starting at the same time, it makes the question, or this part of the question, a little bit more easier. And also, it guarantees that this is going to be the same as this is going to be the same as this, because the third and fourth are the exact same scenarios. They start together and they go at the same speeds. So once we find this, we can just use the same for this and this, and that cuts our time for this question considerably. Okay, well, let's keep the other one in the same screen since it'll help us. Just as before, we've got to set the times equal to each other. So the time for Elaine is 50 pi minus x over 80. And as before, I can use x for Louise's travel distance and 50 pi minus x for Elaine. That's why I got that. And then the times are the same. So time is distance over speed. So for Louise, it's distance over speed. Her distance is x. Her speed is 100. So it's a little bit more simpler than last time. Cross multiply and get 5,000 pi minus 100x is equal to 80x. And therefore 5,000 pi is equal to 180x. Therefore x is 5,000 pi over 180. In lowest terms, it will be 250 pi over 9. And as before, we have to figure out time. So time is this guy again, d over s. X represents my d, so 250 pi over 9. And my s is 100. So when this is all said and done, this becomes 5 pi over 18. All right, 5 pi over 18 is what goes here. 5 pi over 18. And as previously mentioned, this is also going to be 5 pi over 18. And this will also be 5 pi over 18. So that makes our life easier. So now I've got to add up all these guys to figure out the total time. So the total time, is going to be 5 pi minus 2 over 18 plus 3 of those 5 pi over 18. So this looks like 5 pi minus 2 plus 15 pi over 18, and that's 20 pi minus 2 over 18, and in lowest terms 10 pi minus 1 over 9. 10 pi minus 1 over 9 is C for number 22. Suppose that PQRSTUVW is a regular octagon. There are 70 ways in which 4 of its sides can be chosen at random. If 4 of its sides are chosen at random and each of these sides is extended infinitely in both directions, what is the probability that they will meet to form a quadrilateral that contains the octagon? Well, let's draw an octagon and let's discuss this question. All right, so here's my octagon, and I'm going to label these sides A, B, C, D, and so on, right? A, B, C, D, E, F, G, H. Now, I want to explain this question before I give you the solution, because if I jump right into the solution, some of you may not understand what I'm doing. So I want to explain it, and then I'll explain the solution. The first thing, of course, is let's talk about this. These sides are extended indefinitely, or infinitely. So that means basically that you're just drawing lines like this, big long lines, like that. And then what they're saying is if you chose four sides, for example, let's say I chose, let's just give the easiest one. I chose A, C, E, and G. I chose these 4 sides. What they're saying is the lines that are created by extending those, do they form a quadrilateral? And in addition to that, do they contain that octagon? And in this case, the answer is yes. It's clearly a quadrilateral. It's a 4-sided shape, and it contains that octagon. So that's what they're saying. So we have to find all such. Now, before I jump into the solution, I want to sort of illustrate how this would work. I've got to choose 4. Okay, let's say I chose A for my first one. That's fixed, so one possible way of doing that. Then what can I put for the next one? Well, for the next one beside it on this side, I can use either B, C, or D. If I chose E for my next one, and then I chose all the other guys here, there's no way you would be able to make a quadrilateral. And that's important to understand, because if you chose A and E and C, F and G, and extended those lines, you'll see that they don't match. You see what I mean? These lines, they don't meet to form a quadrilateral. And that's important for you to be convinced of. What about going in this direction? Well, my only choices are H, G, and F. And now what I have to do is figure out what goes here. So I can make a little table. A is fixed, but these guys have different combinations, right? Either B and H, either C and B and G, be consistent here, B and F, and then C and H, C and G, C and F, D and H, D and G, and D and F. And then what you have to do is figure out what goes in the middle, this guy. And you analyze the diagram and see what happens. And when you do, you'll get the following. The only choice is E for that one. The only choices here, D and E. You got 2 choices. C, D, and E, all 3 would work here. F, E, and F here. For the next one, C and G, D, E, and F, 3 choices. For the next one, C and F, D and E, 2 choices. For the next one, D and H, E, F, and G, 3 choices. For the next one, D and G, E and F, And for the last one, only E. And when you add up all these, you get 19. Now, I did this just to illustrate how this question works, and I hope it helps you understand the question. Now, if we were to continue like this, it would take a very long time because I did it starting with A. Great, perfect, right? But then I got to do it for B, then for C, then for D, and then for E. And the problem is that there's going to be a lot of overlaps. When you do it for B, you're going to get a very similar list, but 6 of them will be doubles. And then there's going to be doubles here. So this is not the correct approach to doing this question, but the reason I showed you this is to help you understand the question. All right, now I will show you the solution. And by this point, I'm certain the solution will make a lot more sense. Okay, so here we go. Here's the solution. We are already told that there's 70 different ways. The question told us that. And the way they got 70 is actually, some of you are familiar with choose notation. From 8, choose 4. That's how they got 70, just in case you're wondering. Okay, great. Of these 70, a certain number are quadrilaterals, that satisfy the question, and a certain number will not satisfy. So let's say we're trying to figure out x, whatever x is. The other would be 70 minus x, right? These are the ones that satisfy the condition, and therefore that would be our answer. Our probability is going to be x over 70, whatever x is. And these are the ones that don't satisfy. What I'm going to do is I'm going to calculate this guy. And then once I do, I subtract it from 70, and I'll get x. So these 3 figures explain scenarios that don't satisfy. For example, in figure number 1, they've shaded in 4 of the sides. If 4 sides are chosen like that, which are obviously consecutive, you will not be able to get a quadrilateral. As you can see, when this is extended and this is extended, they never meet. So since they never meet, it never forms a quadrilateral. Similarly, figure 2, you got 3 that are consecutive and then 1 sort of outlier. If the 4 sides are chosen in that pattern, again, they will never meet. As you can see, these are parallel. Similarly, in figure 3, you got 2 together and another 2 together. Those will never meet, since when you extend those, they're parallel. So we have to figure out how many are going to be in each of those scenarios. And then we can add them, subtract them from 70, and we'll get x. Okay. So this first figure, they're consecutive. So what I can do is I can choose this one as any sort of starting point. Let's say this is B. And then I choose 3 that are consecutive. All right. So that means that B I have 8 choices for, and then the rest are just consecutive. So they're fixed. So that first guy I have 8 choices for, but then the next 3 that follow are all fixed. So there's only 1 choice for each of those. So that means there's 8. So there's 8 ways of creating a situation like this, where you have 4 consecutive sides being chosen. Okay, now let's talk about these 2 together. These 2 together have an interesting sort of similarity, that they have these guys that were not chosen. You notice how there's 3 in a row that were not chosen? So, how do you choose 3 in a row? If you got 4, there's 8 ways of choosing 3 in a row. Like that. There's 8 ways. Here's 1. Here would be another 1, 2, 3, 4, 5, 6, 7, 8. And then it would go back to the same one that we started with. 8 ways of choosing 3 in a row. And then that 4th one, I can choose it here, or I can choose it here, or I could choose it here. There's 3 choices. I can't choose the here or here because that would make it a consecutive situation like this, where all 4 are consecutive. So for that 4th guy, I've got 1, 2, or 3 choices. So there we go. 8 times 3, 24. So I hope that makes sense. So now to add them all up, it would be 8 plus 24 is 32. And these are the guys that don't satisfy our condition that they would make a quadrilateral. So that 70 minus x is 32. So 70 minus x is 32. Therefore, x is equal to 38. And therefore, my probability is 38 over 70. In lowest terms, it's 19 over 35. And therefore, number 23, the answer is B. What is the sum of all numbers q, which can be written in the form q is equal to a over b, where a and b are positive integers with b less than or equal to 10, and for which there are exactly 19 integers n that satisfy root q is less than n less than q? Let's first concentrate on this inequality. We have n is less than q, and n is greater than the square root of q. We have to do a little bit of fiddling around with the numbers, and when you do, eventually you will get one very obvious solution, that n and 25 for q match perfectly. And like I said, this comes with trial and error, but it would come pretty quickly. There isn't that much of a variation. If you started with 100, you quickly realize that way too many. If you started with, say, 5 for q, way too less. So eventually you'd be able to get this. That means that n is less than 25, greater than 5. So n, since it's an integer, it would be either 6, 7, and so on, until 24. And this is indeed 19 integers. So it fits perfectly. 19 integers that satisfy that inequality. Now, my question is this the only value for q? Well, that's the key to the question. The answer is no. We've got to keep fiddling around. All right, what about if n is, say, 24? Square root of 24. Q, I should say. Well, its square root of 24 is approximately 4.9, and this means that n is going to be either 5, 6, all the way until 23. Well, again, we have 19 integers, 23 minus 4. Perfect. So I got another value for q. Let me write my q values up here. 25, 24. Can I get any more? Well, let's see. How about if I tried 23 for q? When I do, I get the following. I would get about 4.8 less than n less than 23. And that means n is equal to 5, 6, until 22. And then now this is 22 minus 4, which is 18. So that doesn't satisfy. So you're tempted to sort of say, okay, these are the only two. But that's the challenging part of the question. There's actually more values because q is not an integer. They specifically say it's just a number. So because it's a number, it could be something like 23 point something. And that is the challenging part of the question. So let's say n is 23 point something. Let's say it's 23.01, just a little bit more than 23. Let's see what happens. 23.01 square root. Well, this is again about 4.8, and this is 23.01. And that means n can be 5, 6, 7, and so on, all the way up until 23. So now I've got 23 minus 4, 19. That satisfies. So when you start playing around with these different values, and that takes a little bit of time itself, you'll see that Q is equal to 25, that works. Q is equal to 24, that works. But also Q anywhere between 24 and 23, that will also work. Any value that is greater than 23, not equal to 23, because we proved that when Q is equal to 23, it doesn't work. So it has to be greater than 23, but it has to be less than or equal to 24. Okay, so we've got our Q's established. So now we can move on to the next part of the question, that Q is equal to A over B. A and B are positive integers, and B is less than or equal to 10. So let's establish what we have. Q is either 25, Q is either 24, but we have a range for Q. It's between 24, less than or equal to, but only greater than 23. And Q is written as A over B, where B is 1 or 2 or 3, all the way up until 10 integers. All right, so let's work with this. The first one, Q equals 25, not much we can do. It's already in sort of a integer format. So Q equals 25, we leave alone. So I'll just write here Q equals 25. Q equals 24, same thing. It's already an integer. Not much we can do. No need to even bother with this. But all the other values that are between, say, 24 and 23, those have to be represented in this form. So that is what we have to do now. So make a little table here. So these are my values for B, and here I will put the unique forms A over B for any number that is in this range. So we have to make these now. Well, when B equals 1, as I said, it doesn't really make any sense. We sort of have, I guess, 25 over 1, if you really wanted to write them out, 24 over 1, but that's about it. 23 over 1 doesn't work because Q is greater than 23. It doesn't equal 23. So we can write them in for B equals 1. When B equals 2, well, we can write now any value that falls in there. Remember, unique. It cannot be duplicated. It can't be written twice. So unique 47 over 2, that will work. And I think that's it for B equals 2. And just in brackets, I'm going to write what it is as a mixed fraction. I won't do it for everyone, just for a few, just so that you know that this is indeed between 23 and 24. When B equals 3, again, the key here is don't put any doubles. 70 over 3, 71 over 3. And in brackets, I'm just going to put what they're equivalent to as a mixed fraction, 23 and 1/3. And this one is 23 and 2/3. So again, these are indeed in that range. So you got to keep going like this. For 4, it would be 93 over 4 and 95 over 4. So this is a perfect example of how I skipped one. I skipped 94 over 4. Why? Because that's the same as 37 over 2. And 37 is right here. If that was written properly. Maybe some of you noticed that. All right, so this one can't be written because it's a double, right? So we got to get rid of that one. Remember, you have to put unique ones because otherwise you'll get too high of a number. And one last time, I'm just going to write in the mixed fraction. I'm not going to do it for every single one. This is 23 and 1/4. And 95 over 4 is 23 and 3/4. Okay. All right, so you get the hang of it. So now I'll just list them all. For 5, 116 over 5. 117 over 5. 118 over 5. And 119 over 5. For B equals 6, 139 over 6, and 143 over 6. Skipped a few because those are doubles. when you reduce them to lowest terms. When it's 7, you get a whole bunch. 162 over 7, 163 over 7, 164 over 7, 165 over 7, 166 over 7, 167 over 7. 8. 185 over 8, 187 over 8, 189 over 8, and 191 over 8. You skipped a few because those are doubles when reduced. 9. 9, you get a whole bunch. You get 208, 209, 211, 212, 214, and 215. All of these, of course, being over 9. And finally, for b equals 10, you'll get 231, 233, 237, and 239. And that will all be over 10. So how many do we have? I'm just going to count the ones that are from here to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. All right, 31. These guys. There's 31 of them. Now I've got pretty much to add them all up. I've got to add up pretty much everything in this whole table. Time consuming, but the good news is a quick way of doing it. The first thing, of course, is to add these two. That's easy. 25 plus 24. Okay? So 25 plus 24. So this is the sum of all the possible values of Q. Now these guys, these 31, every one of them is 23 point something. As you can see, that's why I wrote some of these in mixed fractions so you can see. Every one of them is 23 point something. And you can also be sure of that because they're all between 23 and 24. So since there's 31 of them, it'd be 31 times 23 for sure. But then you have to add up all of the fractional parts. For example, this gives me a half. But then the good news is for all the other ones, they always add up to 1. You see 1/3 and 2/3 add up to 1. 1/4 and 3/4 add up to 1. And if you were to put all of these in mixed fractions, you'll see that the fractional parts all add up to 1. So you'll get fractional parts adding up to 1 for each pair. So for these, there's 30 of them. There's 15 pairs, and each of those pairs, the fractional part would add up to 1. So 15 pairs, each of them has fractions that add up to 1. So that's just a shortcut. I think it is easier than to manually add up all these fractions. So let's see, this gives me 728 and a half plus 24 plus 25, which is 49. So the total, grand total is 777.5. And that is the sum of all values of Q. So number 24, the answer is C. A new language uses only the letters A, B, C, D, and E. The letters A and E are called vowels, while the letters B, C, and D are called consonants. A sequence of letters is called a word if it does not include the same letter twice in a row and does not include 2 vowels in a row. How many words are there in this language that are 10 letters long and that begin with a vowel? Okay, so let's make a little table. Let's say N represents the number of letters in the word. Number of letters in the word. And then I'll write V at N to be the number of words that begin with a vowel that have that many letters. And then C at N will be the number of words that have that many letters, N, that begin with a consonant. So let's do it for 1 and 2, and then we'll discuss this. So V at 1 would be all the letters, or words I should say, that have one letter and begin with a vowel. Well, how many can we make? A and E, and that's it. So there's only two. And I'll even list them since there's so few, A and E. So just to repeat, V at N represents the number of words that begin with a vowel that have N letters. In this case, it's one letter. Now C at N, same thing. C at N would be the number of words that begin with a consonant that have only one, when N is 1. Well, the only ones are B, C, and D. That's it. So that's 3. And since there's so few, I'll just list them, B, C, and D. Okay, now let's talk about V at 2 and C at 2. Things might get a little bit more interesting here. So we want to figure out V at 2. V at 2 would be words that have 2 letters but begin with a vowel. So they either begin with an A or they even begin with an E. Okay. Well, if they begin with an A, our choices are A, B, A, C, or A, D. If they begin with an E, our choices are E, B, E, C, or E, D. We can't put A, or A, E, or E, E. Why? Because that's a rule. It does not include 2 vowels in a row. So those are not allowed. So based on these, how many did I get for V2? V2 is 6. And these are the 6. So when the numbers are small, you can list them all, but you will find that very quickly these numbers get very big. I'm going to do now C at 2, which is the number I got to put there. C at 2 is basically words that begin with a consonant but have 2 letters. All right? So they're going to begin with either a B, a C, or a D. All right, well, what possible letters can I have? What possible choices? I can have BA, BC, BD, and BE. I can't have BB. Why? Because it does not include the same letter twice in a row. That is a rule. For C, very similar, CA, CB, CD, and CE. And for D, same sort of story, DA, DB, DC, and DE. So as you can see here, I got 12. Okay, so hopefully so far, no problems. What we have to figure out in this question is V at 10. How many words are there in this language that are 10 letters long? So N is 10. And that begin with a vowel. So basically, V at 10. Now obviously, based on what we've been doing so far, that would take forever. I mean, you're going to have to do 3, then 4, then 5. So we've got to come up with some sort of a pattern or some sort of a formula. And this is how we do that. Consider a word of length N that begins with a vowel. For example, it begins with A or E. Since 2 vowels cannot occur together in a row, the second letter of this word must be a B, C, or D. So these guys must be either a B, C, or a D. That means that every word of length N that begins with a vowel can be transformed into a word of length N-1 that begins with a consonant by removing the first letter. So that makes sense, right? So before, let's say we had N. Now we can get rid of that, and the rest would be N-1. Okay? Also, each word of length N-1 that begins with a consonant can form 2 different words of length N that begin with a vowel. So they're just saying that if you have this N-1 word, it can be made into that N-1 word plus the A, or the N-1 word plus the E. That's why each of those N-1 words can form 2 different words of length N that begin with a vowel. When you tack on a vowel at the very beginning, the number of letters goes from N-1 to N. And therefore, we conclude that Vn is equal to 2Cn-1. That is the conclusion here. Based on this explanation, so we can now complete this table. So for example, V3 would be 2 times C2. So C2 was 12, so that's going to be 24. So 24 goes here. All right. So far, so good. Next part. Consider a word of length n that begins with a consonant. So we have n ... letters, and it starts with a consonant. So this guy is either a B, C, or D. Since the same letter cannot occur twice in a row, then the second letter of this word is either a vowel or a different consonant than the first letter of the word. So if this, for example, was B, this would have to be either a C, a D, an A, or an E. Each word of length n-1 that begins with a vowel can form 3 words of length n that begin with a consonant obtained by adding B, C, or D to the start of the word. So, for example, if we had put an A here, what they're saying is this is a word of length n-1. It can be converted to a word of length n by adding an extra letter here. And that extra letter has to be a consonant, either B, C, or D. And B is what we have put there as my example. Also, each word of length n-1 that begins with a consonant can form 2 words of length n that begin with a consonant obtained by adding each of the consonants other than the one with which the word of length n-1 starts. So what that means, that if you have a consonant here, say C, well, that is a word of length n-1 from here to here, but you can make a word of length n by adding a letter here, and that letter can be one of the other 2 consonants. Can't be C, but it can be either D or B. So that's what they mean by this explanation right here. So when you combine those 2 facts here, you get this formula, that C at n is equal to 3 times V at n-1 plus 2C n-1. So for example, C at 3 would be equal to 3 times V at 2 plus 2 times C at 2. So that would be 3 times V at 2, which is 6, plus 2 times C at 2, which is 12. And that is equal to 18 plus 24, which is 42. So the 42 goes here. And then you just continue to make that list using these 2 formulas. These 3 I had already made. You just continue making the list as follows. And what we are interested in is when n is equal to 10, what is the value of V at n? And in particular, that would be V at 10. V at 10 in this list, as you can see, is right here. So there are 199,776 words of length 10 that begin with a vowel. Therefore, the answer to this challenging question is 199,776, and that is choice E.